our world is three-dimensional, right? It's hard to think about the world in 3 dimensions, though for some students it's hard even to do 2 dimensions. So I'm going to try here to give us a 3-dimensional picture of our world on a 2-dimensional screen, and we're going to start with this. This is true for my room, actually, so it's going to help me hopefully not make mistakes. West is to our left, east is to our right, north is away from your screen. Okay, so if you think about looking at your screen and think away from me is north, we draw away with an X. So south is a dot, that's an arrow pointed at your eyeballs, okay, at the camera. So of course this is hard for you to read, but this is up and this is down, okay? And the first thing we're going to think about is a magnetic field created by a wire. And so I have this diagram here for you, and this is what it is, okay? So there is a gray stick here. The gray stick is representing the wire, okay? So it is the thing that is real, and this gray stick has current going through it, and the current's going to be going this way to your right, okay? And what we're going to try to do is these things are supposed to be, the outside parts are supposed to be the magnetic field, okay? So these black arrows represent the magnetic field created by the current in this wire. Right now the current in this wire is coming this way, so right now it's pointed at your screen, okay? And if we, so that'd be out of the page, which is towards, so towards you is south, okay? Away from us is north. So it's pointed south. If we grab with our right hand and grab the wire, your fingers show you the direction of the magnetic field created by the current in this wire. It's going this way, which is counterclockwise, okay? If we were to flip this around, now the current, instead of being towards you, south, is away from you, north. And if we grab the wire with our right hand, like this, the magnetic field goes this way, which is clockwise, okay? But when we draw the magnetic field, we always draw it in the plane that we're looking at. Okay, I've grabbed a piece of cardboard here with a window in it, and this is just going to help us think about what direction is the magnetic field kind of like in this window here. But really it represents the whole plane that we are looking at. So this whole direction here, okay? So let's say that the current through the wire is pointing to our right. So here is our wire. And the current here is going to screen right, okay? So we would grab the wire with our right hand, sticking our thumb in the direction of the wire first, and then grab the wire, and you can see that my fingers are curling around this way, okay? Which means the magnetic field is going around that way, okay? So in the plane of this page, we always take this as our plane that we're looking at. So like this window here, what direction is the magnetic field directly above the wire in the plane of that window? Okay, so we grab the wire right with our right hand, and up there the magnetic field lines are coming out of the page. You can hopefully see my fingers are trying to poke through the page like this. Okay, so magnetic field lines are coming out of the page there, so this way. So that would actually be south. I don't really care so much usually unless somebody's going to ask about that, but the magnetic field lines are coming out of the page. Down here below the wire, what direction is the magnetic field? Well, the magnetic field lines are coming around this way, and they're going into the page down there, going that way. So for into the page, we would draw X's, okay? Into the page, the magnetic field is going away from us. So above the wire, we would draw dots. I'm sorry, X's. I'm sorry, dots. Out of the page up here, dots. Okay. Below the wire, we would draw X's. The magnetic field is going into the page down here below the wire. And we always draw from our reference point from the plane of this page. Okay. If the wire were like this, vertical, and my current is going up. And remember, this is a conventional current. We're pretending that positive charges are moving up the wire, when in reality negative charges are moving down the wire, but it doesn't matter. It won't change the situation at all. So right here to the right, or in this case that would be east in this room, to the right of the wire, if I grab the wire like this, with the current's going up, the magnetic field lines wrap around and they're pointing into the page through that window. So to the right of the wire, we would draw X's, okay? Because the magnetic field lines are going into the page on the right, which happens to be north in my room. Away from us is north. And over here, the magnetic field lines are coming out of the page. As I grab the wire, over here they're coming out, so we would draw dots over here. Okay? Because the magnetic field is going around this way. Now, in closer to us than the wire, the magnetic field lines would be going this way, which is east. So if somebody said, you know, just south of the wire here, what direction is the magnetic field? The magnetic field is east. North of the wire, which is this way, farther away from the from us than the wire, the magnetic field lines are going this way, which is west. So try to see if you can imagine this from above: north, south, east, and west. Okay. What would happen if the the current were going to our left? Okay. So if the current is now going to our left, we would grab the wire with our right thumb pointing to the left. Below the wire, the magnetic field lines would be coming out of the page at us, so dots. And on top of the wire, the magnetic field lines are going away from us, which is X's. Okay? So when we draw it, we draw in the plane that we are looking at, like from our perspective. Take this wire and make a plane out of it. What direction is the magnetic field? Okay? What would happen if the wire is turned like this, where this current now is pointing toward you? So the current is pointing south toward you. Then you would grab the wire like this with your right hand. The magnetic field lines are going this way, which is counterclockwise. And in the plane of this page, like the perspective, like in the plane of the wall, okay, we would draw magnetic field lines going that way. We would draw a circle here, and then a bigger circle perhaps, to show that they are actually concentric rings. Like there's a magnetic field here that's really strong, and then one a little farther out that's a little weaker, and a little farther out that's weaker, and a little farther out that is weaker. I was trying to make these be, you know, multiple circles, but it didn't work all that well, and but it helps me hold it. But these are magnetic field lines. Really, the lines don't exist. It's just they're drawn to show us the direction. But the lines show us, if you draw them well, that the closer the lines are together, the stronger the field. As you go farther out, the lines get farther apart, or should be drawn farther apart, I should say, to show that the field is getting weaker. The farther away we get from the wire, the weaker the field is. But it's always going around this way, in this case, which is counterclockwise. So we would draw counterclockwise. If somebody asks us just east of the wire, what direction, or just to the right of the wire, from our perspective, page right, what direction is the magnetic field? Well, what direction is the magnetic field right there? To the right of the wire, which is east. It's going this way here, right? It's going around like this, so it's going up, away from the ground. Above the wire, you know, over the wire, it's going this way, which is west. To the left of the wire, or west of the wire, it's going down toward the ground. And then below the wire, it's going this way, which is east. Okay, so that's the magnetic field from a current carrying wire. Remember, we imagined that the current is positive charges that are moving. Okay, and that is the magnetic field created by them. If you wanted to think of the electrons moving, the electrons would be moving this way. And nobody does this, but to show you once what you would do, you would use your left hand. You would use your negative charges moving this way, would create a magnetic field like this. But guess what? If you use your left hand and point in the opposite direction, you get the same result. Okay, the magnetic field goes this way, whether it's positive charges moving towards us or negative charges moving away from us. You just switch which hand you use to help you figure out which way it goes. Okay, so that's the current, or the magnetic field created by a current carrying wire.